Okay. All right. All right. Good evening, students. It seems still students are joining in. So joining in, let's wait for another like 3 minutes and we'll start. And am I audible clearly? Online students? Yes. Okay. Thanks. So since students are joining in, it's 7:04 now. I'll start at 7:07. Right? We'll wait for another 3 minutes and we'll start. So you can prepare yourself for the class. This will last for 3 hours, right? If you are joining for an online class for the first time, so what you can do is you can grab a water bottle or snacks or something like that if needed, without going here and there during the class, right? So prepare yourself and get ready. I'll start in another 2 minutes. Okay. All right. Good evening again, and welcome you all to the new batch of 2027 A-levels. So I hope everyone here are the ones who didn't start your classes after O-levels, or there can be students who have missed the initial lessons, the first unit, or maybe first parts, first lessons of physics from the beginning, right? All right. So now the target batch here, target batch in the sense, target group here is the students who haven't started the classes after all levels, no? Right? So therefore, we will be starting everything from scratch in this new batch as well. And first, before jumping onto the lesson, first I'll explain the plan of this class, and we'll go to the lesson, right? The plan is like this. The plan is like this. Now, you are stepping into A-level physics, or maybe you have chosen science stream just after O-level results. And now, if you are doing combined maths, or if you are doing biological sciences, biosciences, whatever it is, now you are doing physics. That's why you are in this meeting, right? That's why you are in this class. So now the plan of this class is like this. First thing is, now compared to the first batch, you are starting this more than 3 months late, right? More than 3 months late compared to the first batch of 2027, right? But even though you are starting late, that doesn't mean you are going to face your exams late, no, right? Both of the batches will face the exam 2027 at the same time. So therefore, this class is going to be starting from scratch and going to be a faster class compared to my regular class, and I'm going to merge this class with my regular batch after 3 months, right? So this class is, this new batch will be separated for another 3 months. So we are starting today. Give me a second. Right. So we are starting today from scratch, and since you are a little bit late, around 3 months, I'll be covering the things a little bit faster, right? Not too fast, a little bit faster compared to the regular batch, right? And after 3 months of time, will be merged with the regular batch, right? Now for the regular batch, this week they are starting vectors, and this week is going to be the 15th day of the class, right? So that's the delay you have. Now I'm going to cover up that delay by teaching you somewhat faster compared to the theory batch. And after 3 months of time, which means after 12 weeks of time only, you will be merged with that regular batch, right? So once you are merged, then there are no 2 batches for 27. There will be only 1 batch, that's the regular batch, right? So the plan of this class is like this. This class will be only an online one, and the fixed time for this class is this. This will be happening on every Tuesday from 7 p.m. to 10 p.m. right? And since this is only an online class, now about the tuts, since you are asking about the tuts, now after this class, now today, since it's the very first day, this is a pre-session, this is a free day, this is an open day. Now after this day, I'll be sending you the registration links. So if you have registered, now from my side, what I can do is, I'll be sending you, I'll be posting you the hard copies of tuts required for the class. So therefore, when registering into the class, make sure that you are entering your home address, your living address there, because that will be the same address I'll be using to post tuts. That will be the same address I'll be using to post tuts, right? So that is very critical. And usually we will be sending all tuts in the first week of the month, right? We'll be sending all the tuts in the first week of the month. So therefore, make sure that address, that's the very first thing. Now after today, I'll be sharing all the links to your groups. Right now, you are already in the group, no? So that's why you are in this class, and you are registered. Since you are registered only by sending your name, school, and other basic details, after the registration only you will be in the group, right? So since you are in the group only, you are joining the class today, and therefore now after today, I'll be sending the registration link separately to the group. So therefore, again repeating, make sure that you are using your living address or the home address, a correct address when putting the address there, because that will be the address I'll be sending you the tuts, right? I'll be sending you the tuts. All right. Now, today itself we'll be starting the syllabus. And now, since you are new here, just know that now after O-level results and everything, right? And sometimes you might have got your expected O-level result, or sometimes there can be students who haven't got the expected results, or sometimes there can be students who are like neutral, right? in any state you are, your O-level result is not going to be directly impacted or directly impacting on your A-level result, as long as you work hard here in your A-level journey, throughout your A-level journey, right? So therefore, if you are starting your classes this day, today onwards, right? So just know that your A-level journey will be completely independent of, irrespective of your O-level result or your O-level journey. And A-levels is not something that is comparable with O-levels, right? They are completely two different things, right? If A-level is 1%, if O-levels is 1%, A-levels is going to be like 1000%, something like that. Right? Cannot be compared. So therefore, start all your studies from today onwards, not only for physics. Now you are starting physics today, and sometimes you might have already started the other two subjects, or sometimes not. So whatever it is, have a fixed class here onwards, right? Because this is not a good time to switch classes and check classes because you are already late, right? So maximum spend up to like 2 weeks to select or to finalize a class, and then you have to put your maximum effort and start working the first day onwards, right? The first day onwards. Always in A levels, that's the key behind A levels. Key in the sense now, this is not something that we can do the last moment things and go through the exams. Always the continuous, consistent effort has to be here in A levels, right? For any subject, right? That is not only just for physics. For any subject, that continuous effort has to be there. Consistent or continuous effort has to be there. So therefore, have a courage, have a dedication that you are starting today, and now you have around 2.5 years of a journey from this point onwards, right? That is actually less than 2.5 years now, because now we are in July, and for you it's actually around 2 years and 3 months of time before the exam. So make sure that you are utilizing that time to the fullest and doing your thing and giving your best shot for the exam for A levels, right? Okay. All right, then we'll start. Before starting, do you have any questions or anything to clarify? And always, you can use the chat box here to ask me anything at any time, so I can see all your questions here. If you need any clarifications during the class, if you need anything to know from my side, you can always drop me a text, drop me a message through the chat box, right? And I always encourage your engagement because this is a fully online class and I'm just talking to the camera and I'm looking at the screen only. I don't see your faces, I don't see the physical students, right? So therefore, to make sure that you are engaging with the lesson, I always encourage you to use the chat box and engage answering questions. And if you have any clarifications, if you need any clarifications, you can always get them clarified through the chat box, right? Okay, any questions before starting? Because we are going to move on to the lesson. We are going to move on to the lesson without having any delay. Questions? Can we get recorded? Yeah, this session will be recorded, right? This session will be recorded, and now always you are encouraged to be in the live class. And if there is a reasonable reason that you didn't attend to the live class, you can request the recording from me. Then I'll share the recording with you, right? All the sessions will be recorded, so don't worry, all the sessions will be recorded. And yes, once you requested the recording from me, you can get it, right? Any other questions? Any other questions before starting? No, right? Right. All right. Then let's move on. Okay. All right. Right. Okay. So now, for most of you, this will be the first day, starting day of physics. No? So first tell me what physics is. Any thoughts about what physics is before moving on to our first lesson, first unit? What is physics? What do you know about physics? What is meant by physics? Right? Because you have dealt with physics to some extent, to a small extent in your O levels as well. So what do you mean by physics? What do you mean by physics? Any thoughts? Any thoughts? There are no any correct or wrong answers. Just share your thoughts. Any thoughts? What physics is? Any thoughts? What do you think? What is physics? So after combining this class with the normal continuously, the class will be given online. Yeah. Now, when it comes to my regular batch is actually a hybrid batch, right? That's a hybrid batch. Now, once the class is merged, if you are living in and around Colombo, you can come to the class physically as well. The physical class is in Bambalapedia, Maxima College, Bambalapedia, right? Now, don't mess up the things. I'm talking about the regular class. Huh? You can attend the regular class once this is merged with the regular class, and that will be a hybrid class. So therefore, the online session will be continuously there, right? Online session is always there. So don't worry about that. Yeah, it will be given online. Yes. Yeah. Any answers for my question? Any thoughts about physics? What is physics? Anyone? So as I told you, there are no correct or wrong answers. Just tell me if you know anything, even a single word about physics. What is physics? Anyone? Anyone? Calculations. Calculations. Yes, calculations do involve in physics, but just mere calculations doesn't mean physics, right? Calculations do involve. That's correct. Yeah. Any other responses? Good that you respond. The study of nature and properties of matter and energy. That's a good one. That's a good one. Study of nature and properties of matter and energy. That's a good one. Any other thoughts? Any other thoughts? Now, when it comes to physics also, there is no a single definition, right? So we can define physics in different ways, right? So I'll define in one way. Define in the sense I'm going to introduce what physics is, right? Physics is something like this. This is a study, no? Physics is a study. This is a study on physical behaviors, right? Physical behaviors in the sense there can be motions, linear motions, projectile motions, circular motions. So likewise, they are physical behaviors of objects, right? Physical behaviors, radiation, conduction, convection, everything, they are physical behaviors. Evaporation, vaporization, there are plenty, right? So simply, physics is a study on uh, physical behaviors, physical behaviors uh, using observations, right? Simply, physics is that. This is study on physical behaviors of objects, right? Physical behaviors of objects, right? We are not going to write what physics is, just know what physics is because you are starting learning physics today now, right? So physics is the study on physical behaviors of objects, right? Physical behaviors of objects, right? So just know that. And now we are going to start off with our first unit. In our physics syllabus, we have 11 units altogether, and today we are starting unit 1, right? Put the heading as unit 1. Put the heading as unit 1 measurements. Put the heading unit 1 measurements. Unit 1, measurements. Unit 1, measurements. Right? Unit 1, measurements. Measurements. Right. So under measurements, the first subheading is physical quantities. Under measurements, first subheading is physical quantities. Physical quantities. Physical quantities. Right. Now listen. So this is the very first thing you are going to learn today. Right. This is the very first thing you are going to learn today, physical quantities. Right. Now, as I told you, physics is the study on observations about physical objects, physical behaviors of objects, physical behaviors. Right. Now, when we study on physical behaviors, right? When we study on physical behaviors, to describe about physical behaviors of objects, to describe about objects, we need physical quantities. To describe objects or to describe behaviors, right? Objects and behaviors. Objects are like pens. Now this is an object. Pen is an object, right? Now if I need to explain about this, I can explain using length of this pen, mass of this pen, area of this pen, right? Color of this pen, right? So likewise, there are things that I can use to explain about this. No, this is a physical object, right? To explain, to describe physical objects, right? We use physical quantities. Other than that, to explain physical behaviors, behaviors are simply motions. Behaviors are motions. Now, if I need to explain about a motion, right? So let's say a car starts motion from point A and it ends the motion at point B, and A to B it moves during, let's say, 2 minutes. Now I had to use a time to describe that motion. Is that clear? So likewise, physical quantities are used to describe about physical objects and behaviors, right? Now, you should have a small understanding by now that now if I use length to describe about this, length is a physical quantity. And if I use mass to describe about this, mass, let's say 1 kilogram, assumptions, 1 kilogram. So that's a physical quantity, mass. So if I use, let's say, time to describe about something, time is also a physical quantity. So likewise, to describe about physical objects and behaviors, we use physical quantities, right? Very simple as that and very straightforward as that, right? So as the first point, write down, you can put an asterisk mark like this and write down first point. So always you will be writing the note in point form. Always you will be writing the note in point form. Don't write in passage form, because always you should see the important parts, important things in the note as points. So therefore, always I'll be giving you the note as points. So you can also get used to write the note as points. Don't write passages and passages. Then you can't find. You can skim through the note and find the relevant things, the essential things when you study. Right? That's the reason. Okay. First point. Write down. Physical quantities are used to. Physical quantities are used to describe describe about physical objects. Describe about physical objects and behaviors of physical objects. and behaviors of physical objects. Right. Next point. There are 7 fundamental physical quantities. There are seven. There are seven. No? There are 7 fundamental physical quantities. There are 7 fundamental physical quantities in physics. 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 Right. All right. Now listen again. The idea is that now, even though we have thousands of physical quantities in this world, right, all of them are derived from 7 fundamental physical quantities. 7 fundamental physical quantities means, or the fundamental physical quantities means, fundamental physical quantities cannot be derived using someone else. Right? They are fundamentally there. So using fundamental physical quantities only, we can derive other physical quantities. Right? So today, by the end of the class, you will be seeing how other physical quantities are derived and how the units of physical quantities are getting derived. Right? By the end of the class, you will leave the class. With that knowledge on deriving physical quantities. Right? So we have some way to go. Now we are at the very beginning yet. Right? So idea of fundamental physical quantities means they cannot be derived using other physical quantities. They are fundamentally there. Right? Okay, as the next heading, write down fundamental physical quantities. Next heading, fundamental physical quantities. Next heading, write down fundamental physical quantities. Fundamental physical quantities. Fundamental physical quantities. Right? Now, as I told you, we have 7 fundamental physical quantities. Let's see what these 7 fundamental physical quantities are. Right? 1, 2, 3, 4, 5, 6, 7. We have 7. Right. First one is mass. The idea is mass cannot be derived or mass cannot be explained using other physical quantities. Now, as an example, now if I say mass of this pen as 1 kilogram, now I can't explain what mass is without using the word mass. That's the idea. I can't explain what mass is without using the word mass again. That is what it says. That is why it says it cannot be derived using other physical quantities. Now, if I say length of this pen, now I can't explain what length is without using the word length again. Now, if I say it is from here to here, then I have to say that is the length from here to here. No? I have to use the word length again. Right? That's the idea. When it comes to fundamental physical quantities, they cannot be explained, they cannot be described using other physical quantities. Always we have to use that same word itself to describe them. They are the fundamental ones. So first one is mass. Then length. Let's see one by one. Length. Time. Amount of substance. Amount of substance. Right? Then electric current. Thermodynamic temperature. Thermodynamic temperature. And finally, luminous intensity. Right? So from these 7 fundamental physical quantities, there will be some physical quantities you have already heard, you have already come across, and some of them that you haven't heard before, right? The purpose of this lesson, measurements, and now we are still in physical quantities, and the next main part we are moving on is units. So by the end of the first part of this lesson, units, you will know how these physical quantities work and how the units of other physical quantities are getting derived using these fundamental physical quantities, right? So that's the proceedings. That's the proceedings of this lesson, right? So repeating again, these are the 7 fundamental physical quantities, and they cannot be derived using other physical quantities, right? And you have to know all 7 fundamental physical quantities here onwards, right? Mass, length, time, amount of substance, electric current, thermodynamic temperature, luminous intensity. There's a difference between temperature and thermodynamic temperature. So we'll explain in the coming part. So just know that it should be thermodynamic temperature, not just temperature, right? Because when it comes to temperatures, there are different types of temperatures in A levels, like relative temperatures, absolute temperatures, thermodynamic temperatures, likewise. So therefore, we have to be specific as thermodynamic temperature. And this also, don't write this as just current. Don't get used to write this as just current. That should be electric current, because when it comes to currents also, there are different types of currents we have in our A level syllabus, right? In physics, actually, in physics we have different types of currents. Therefore, if there is electric current, we have to say electric current. All right. So take this down. These are the 7 fundamental physical quantities. Take it down. Take it down. Take it down. And always, if I ask something, ask a question from you, please do engage with me through the chat box, especially because this is an online class. Because I need to make sure, I want to make sure that you are with me and on track. And if I ask that if it's clear, so at least now if it's too difficult to type something, at least put a thumbs up reaction or something to the Zoom chat box, right? Then I will see, and I know that you are on the track now. Right, finish. As the next heading, write down units. Next heading, units. Units. Right, units. All right, now listen. Now you know what physical quantities are, and you know what fundamental physical quantities are. Now, as a very simple example, let me take this pen. Now I'm going to describe about this pen, right? Now from these fundamental physical quantities, to describe about the pen, now let's say I'm going to use length. Now I'm going to describe about the length of this pen. I need to describe about the length of this pen. Now if I'm explaining the length, now I have to say this length in terms of a unit with a value, no? In terms of a unit with a value. Now, as an example, you all know that I can say this pen's length is 10 centimeters. 10 is a number, 10 is a value, and centimeters is a unit, right? 10 is a number, and centimeters is a unit. So therefore, units are this standard amount. That's a standard amount. Now, if that's a 1 centimeter, that's a standard reference amount that we use to explain or the measure, let's say, measure physical quantities. Units are the standard amount to measure physical quantities, because ultimate purpose of having a unit is to measure, right? If that's a length, it should be measurable, and if there is a mass, it should be measurable, right? And if there is a temperature, it should be measurable. So likewise, units are used as a standard amount to measure physical quantities. And always, unit can be and unit should be stated as a numerical value. If there is no numerical value, there is not going to be a unit, right? Numerical value එකකින් මට කියන්න බැරි නම් ඒක unit එකක් නෙමෙයි, right? Now if this is 10 centimeters, which means 10 is a numerical value, centimeters will be the unit. So therefore always the standard amount that we use to measure physical quantities with the numerical value, that's a keyword, with the numerical value is called a unit, right? There should be a number, there has to be a number, there must be a number that we have to use with the unit, along with the unit, right? Unit එකක් නිකන් කිව්ව කියලා වැඩ නැහැ. There's no meaning if I say a unit all alone. If I say centimeters, there is no meaning. If I say centimeters, there is no meaning. And I say this is centimeters, no meaning, that's meaningless. This is centimeters, this length is centimeters, meaningless. So therefore always the unit becomes meaningful with its numerical value. So therefore having a numerical value for a unit is a must, right? Okay, hope it's clear. Put another asterisk mark here and write down under units, write down units are the standard amount. 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 Used to measure standard amount used to measure standard amount used to measure physical quantities, in numerical values. In numerical values, this is very important. In numerical values, in numerical values, right? Sir, can you say seventh one again? Seventh, you mean this luminous intensity, luminous intensity, right? Listen again. Now as we have 7 fundamental physical quantities, these 7 fundamental physical quantities has 7 fundamental units as well, because to measure these physical quantities we have to have a unit, no? Now without having a unit we can't measure these physical quantities. So therefore to measure these physical quantities we have units. So as we have 7 fundamental physical quantities, we have 7 fundamental units to measure them, right? Now let's see what the 7 fundamental units are, right? As a next heading write down fundamental units. Next heading fundamental units. Next heading fundamental units. Okay, so quickly take down this list again under units, then I'll explain the unit one by one. Take down this list of 7 fundamental physical quantities again under fundamental units. Take down this again, 3, 4, 5, 6, 7. Take down the list again, this one. Take down this list again under fundamental units. Take it down. Take it down again. Take it down again. Okay, now let's see what the fundamental units, of these fundamental physical quantities are, right? All right, let's see one by one. For mass, first one, mass. Look at here, look at the board, look at here, mass, right? For mass, fundamental physical quantity is kilograms. So make sure that you are writing simple K. We have these kilos and other things. They are called prefixes in the coming up parts. So here still we are still in the identification of fundamental units. So therefore, just for time being now, write simple K. That is not capital K, because capital K refers to kelvins. Simple K refers to kilos. Right? Just know that. Kilograms. And length, meters, time, seconds. Now, if any one of you needs this in words, needs to write this unit in words, you can take it down in words within brackets. I'm just mentioning the symbol. Now, if you need to write words, right? Now this is kilograms, and this is meters. So likewise, if needed, you can take it down. No? And S means seconds. And amount of substance that you know from O levels. In which unit you measure amount of substance? In O level chemistry also you have. Using which unit you measure amount of substance? Anyone? Quickly. A very simple question. Quickly. Anyone? Using which unit you measure amount of substance? In chemistry? Moles. Yes, good. Yes, moles. Good. Right? Moles. So amount of substance, moles. MOL. Moles. Electric current. That is also something you know. Electric current. Right? In O levels also you have come across this. Electric current is measured in amperes. Capital A. That is called amperes. And next, thermodynamic temperature. Thermodynamic temperature is measured only in kelvins, capital K. Only in kelvins. This is not degrees Celsius. Right? Degrees Celsius or degrees Fahrenheit, they are for relative temperatures, not the absolute temperatures. Absolute temperatures are the thermodynamic temperatures. Right? So it should be measured in kelvins only. This is kelvins. And luminous intensity, this might be named to you. This is measured in candelas. The unit is simple C, simple D. That is called candelas. That is called candelas. Right? Take it down. Take down the units. Write it down. And if you got any questions, if you need anything to clarify from my side, you can always question me. And I warmly welcome your questions. I warmly welcome your questions here. Right? So you can always question me if you didn't get anything. Okay, take it down. Finish. Okay, by now, listen. By now, you have some idea about what a physical quantity is, right? Now, before starting the class, you didn't know anything about physical quantities, no? Now, at this point, so far, now you have an idea about what a physical quantity is, right? And you know what a unit is. And you know what 7 fundamental physical quantities are with their 7 fundamental units. So these are the 7 fundamental units, right? And these are also called SI units. SI means Standard International, SI, right? So you might have heard the word SI. SI means Standard International, SI units. They are called SI units. SI units, right? Okay. Any questions up to here? Because basic introduction about the units, physical quantities are given here at this point. Any questions up to this point? Quickly. So if there are no any questions, I'll be quickly moving to the next part. So quickly ask me, and if that is clear up to here, just say it's clear. Any questions up to here, or is it clear enough? All clear. Good. Others? So if it's too difficult to type, at least put a thumbs up. At least put a thumbs up. You can put reactions on Zoom, no? Yeah. Clear. Salman, clear. Good. All right. Good. Very good. All right. Okay. Now we are going to move on to the next part. Next thing you are going to learn today, right? So that is about deriving physical quantities. That is about deriving physical quantities or derived physical quantities, right? Now, as I clearly said, these 7 fundamental physical quantities cannot be derived using other physical quantities. They are fundamentally there. They cannot be derived. That is why they are called fundamental physical quantities. They cannot be derived. Now, using these seven physical quantities, all other fundamental physical quantities are derived, right? Using these 7 fundamental physical quantities, all other physical quantities are getting derived, right? Now let's see how the physical quantities are getting derived using these physical quantities, right? All right. As the next heading, take down derived physical quantities. Derived, right? I'll also write here derived physical quantities. Derived physical quantities. Derived physical quantities. Derived physical quantities. Okay. Look at here. So we'll go one by one. Say number one. Wrong number one. Okay. Let's go one by one. So as the first derived physical quantity, I'm going to take area. As the first physical quantity, first derived physical quantity, I'm going to take area. Say area. Now, area is not among this list, no? Area is not among this list. So, any physical quantity which is not in this list means that is a derived quantity, yeah? Because only fundamental physical quantities cannot be derived, which means all other physical quantities are derived. So, therefore, any physical quantity which is not in this list of 7 are derived physical quantities for sure, right? Okay, area. So all of you know that area is length into breadth, no? Or we can say length into width. Area is length into width. As an equation, look at here. Area can be written as length times width. So everybody know this. Area can be written as length times width. Right? Now let's say we need to identify. Listen, because this is the very first derived physical quantity you are going to look at. Right? Now let's say I need to identify, I need to get the standard unit of area. I need to get the SI unit of area, right? So what we can do is we can substitute these units using fundamental units accordingly, accordingly, and get the respective standard unit. So this is how it is done. This is how it is done. Look at here. We know, and another small thing, to denote units, which means to say that we are considering units. In physics, we use parentheses. Parentheses are simple brackets, right? Now, this is the equation. And if I put brackets like this, which means units of area. Bracket එක දැම්මොත් units of area කියලා words වලින් ලියන්න ඕනේ නැහැ, which means brackets denote units of area. Now, units of area can be written as units of length. Look at here. This can be written as units of length times units of width. No. So if I need to say units of, I need to put parentheses like this. I need to put simple brackets, parentheses like this. Okay. Now, from this fundamental list, we have to pick the relevant units and substitute here. Look at here. Length. Length is the length, no, that is in meters. That is measured in meters. Length is measured in meters. Substitute these values. And width, right? Width is not in this list, but we know width is also a length. Width is also length, right? Length and width. So width is also length. So therefore, width is also length and width is also measured in meters. Width is also measured in meters. Meters times meters, you get square meters. Meters times meters, you get square meters, right? So I hope it's clear, because if you multiply x times x, right? This is x to the power 1, this is x to the power 1. So x times x means x squared, no? So likewise, meters into meters, that is square meters. Right? So likewise, see, now using these fundamental physical quantities, we can derive other physical quantities we need. Now here onwards, we will look at physical quantities one by one and with their SI units, right? With their SI units, we are going to look at the physical quantities one by one. Clear? Okay, good. Right. So is this clear? Is this exercise clear? Now this is what we are going to keep doing here onwards. I'll always give you a derived physical quantity with an equation, or as an equation. You have to substitute the correct units from here, and we are going to obtain the SI units of that derived physical quantities. That's a thing which is coming up, right? So I use area as the simplest one. Clear? Okay, good. All right then. Take it down. First one. Take down the first one. Take down the first one. Area. Take it down. Listen, until you complete your registration, for the first week and probably for the next week, I'll be sharing the soft copy of tudes when needed, right? Because now once you are registered, only I will get your permanent addresses, no, right? So once I get your permanent address, only I can post all of your tudes. So therefore, once your registration is completed, tudes will be posted to your home address, right? Finish. Let's see the second one. Problem number two. Volume. First, write down the equation. Volume is length into length times breadth, or we call width, times depth. This is called a volume. Right? This is called a volume. Now, if you need to get the units of volume, right? Use parentheses. Use parentheses to say that you are going to consider units. To say that you are going to consider units. Right. So putting this means units of volume, units of length, units of width, units of depth. Likewise. Okay. So find it out and tell me what's the unit of volume. Right? What's the unit of volume? So first, for the initial examples, for the first examples, I'm taking the units that you already know to make it more comfortable with you. And by the end of the lesson, you will learn all physical quantities, all derived physical quantities, all in the sense the main ones, main physical quantities that we need to know in this lesson. Right? So very simple thing. Length is a length. So that is measured in meters. Width is also a length. That is measured in meters. And depth is also a length. Depth is also a length. That is also measured in meters. So meters into meters into meters, that is cubic meters. Cubic meters. Cubic meters. Right? Cubic meters. Next one. Next one. Number 3, write down velocity. Number 3, write down velocity. Number 3. Number 3. Velocity. We have symbols for velocity. So therefore, when we have symbols in equations, we will always mention symbols. Velocity is denoted by V. Write down V. Velocity is displacement over time, as you know from O levels. Velocity is displacement over time, as you know from O levels. But when it comes to A levels, that will be updating a little bit. That is not just the displacement, that is called the change of displacement over time, not the displacement. In O levels, since you are like not matured, immature students, it says displacement over time. But when it comes to A levels, now always you will be learning the standard exact correct equations, right? Because now you are matured after O levels, and now you are moving on to A levels. And in A levels, all the equations will be the exact standard equations. So therefore, today onwards, get used to this new type of equation, that is not displacement over time, that is change of displacement over time. Right? You will see the impact of that in the coming parts in A level physics. Right? That is not the displacement, that is actually the change of displacement. Right? Change. So this is change of displacement. Change of displacement. We denote it by delta S over time. And time is denoted by simple T. If anyone who doesn't know about delta, this triangle, this symbol is called delta, right? Delta refers to, let me mention it somewhere here, delta. This is called delta. This symbol, this is a symbol, delta, and this refers to change. Right? This refers to change. Delta. Delta means change. Delta. This is called delta. That's a Greek symbol. Delta is a Greek symbol that refers to change. Change. अभी change के लिए use करना symbol है delta. Change of displacement, no? Delta S. If there is just S, that is displacement. If there is delta S, change of displacement. Right? Symbol लेगा. Right? Delta. And any change is written as, just listen, any change in physics is written as final value minus initial value. Right? Any change in physics is written as final value minus initial value. Change is also called the difference. Right? Final value minus initial value. It's a change. Okay. Now, if I write the equation in terms, it will be like this: V equals delta S over T. V equals delta S over T. Right? Okay. Now find it out, give it a try. Now, if I need to find units here, units of V, units of delta S over units of time, put that parentheses, put the simple bracket. Okay, numerator, numerator, first numerator, let's say numerator, delta S, change of displacement. Displacement is you know what displacement is from all levels? Displacement is the shortest distance between 2 points now. So displacement is a length. From our list, from our fundamental list, displacement is a length. ඒක තමයි ඔයා චෙක් කරගන්න ඕනේ. මොකද දැන් ෆන්ඩමෙන්ටල් ටික යූස් කරලානේ අපි මේක ඩිරයිව් කරන්න යන්නේ. හරි? ඒතර මේ ඔක්කොම ඩිරයිව් කරන්නේ ෆන්ඩමෙන්ටල්ස් ටික යූස් කරලා. ඒතර මේ තියෙන යුනිට්ස් ෆන්ඩමෙන්ටල් ලිස්ට් එකෙන් හොයාගන්න ඕනේ. මේකට ලින්ක් කරන්න පුළුවන් කොහොමද කියලා. Displacement. So displacement is a linear length. That's linear. So therefore, displacement is a length. Change of displacement is a length minus length, because change is final value minus initial value. No? So therefore, change of displacement is a length minus a length. Length minus length is also a length. No? Is that clear? If I subtract 2 centimeters from 10 centimeters, that is 8 centimeters. Otherwise, it is not going to be 8 kilograms. So therefore, length minus length is a length. A mass minus mass is a mass. So likewise, the same unit remains if you add or subtract. Hope it's clear. So therefore, delta S is also a length. Delta S is also a length. So therefore, this is in meters. That is in meters. And time is a fundamental physical quantity, and time was measured in seconds. Seconds. So therefore, simplify this. This gives us ms minus 1 meters per second. It gives us ms minus 1 meters per second. Meters per second. So that is how the SI unit of velocity, SI unit of measuring velocity has become ms minus 1, because it derives from fundamental units. Okay, take it down. Now let's go one by one. Okay. Next one. Okay. 4. Right here. 4. Acceleration. That is denoted by simple A, and that is also like this. That is not velocity over time. That is change of velocity over time. That is change of velocity. Change of velocity. So we denote it by delta V. Delta V over time. Change of velocity over time. Okay. So as an equation, as a symbolized equation, we can state this as simple A equals change of velocity delta V over T. Okay. Do your thing and find units of acceleration. And once you got the unit, you can put it into the chat box. Right? Once you got the unit, you can put it into the chat box. Quickly. ms minus 2. Good. See? Then, now if we are determining units, make sure that you put simple brackets like this, right? Make sure you put simple brackets like this. Otherwise, if you didn't put the simple bracket, which means that is just the equation. Usually, equations are considered for plug values and getting answers. That's what equations are for. If y equals 2x minus 1, once you plug the value of x, you will get y. That's an equation. But if we are using an equation to derive units, specifically, that's why we use parentheses, simple brackets, to say that I'm using the equation to get units, right? Otherwise, the prime objective of an equation is plug the value and get the output, correct? So equation එකක්ම units one use කරන හින්දා use කරනවා නම් අපි ඒ හින්දා brackets දානවා, right? Change of velocity, look at here. Change of velocity is final velocity minus initial velocity, no? That's final velocity minus initial velocity. A velocity minus velocity. Final velocity is also a velocity. Initial velocity is also a velocity. A velocity minus velocity is a velocity, right? So units of velocity is already determined. Then this has to be ms minus 1. And time is in seconds. So therefore, this is ms minus 2. Units of acceleration is ms minus 2. Units of acceleration is ms minus 2. Clear? Next one. Next one. Number 5. Number 5. Force. Force. We denote force by capital F. And force can be written as mass into acceleration. So you know F equals ma, no? Mass into acceleration. Simple A. Now, as an equation, this can be written as F equals ma, m times a, ma. F equals ma. Right? F equals ma. Okay. Right? Right? Now, one by one, we will be looking at the derived units of derived physical quantities like this. Right? Any answers? And if you got any questions, anything to clarify from my side, feel free to ask anything. Feel free to ask anything at any time. Right? Doesn't matter. You can always question me if you didn't get anything. You can always question me. And even after the class also, if you get any questions while you study, right? You can see my number from the WhatsApp group you are in. So you can put a message to that WhatsApp number, and when I'm free, I'll definitely reply. kgms minus 2. Good. Right? So units of force is units of mass into units of acceleration. Units of force is units of force is units of mass. Mass is one of the fundamental physical quantities. Very straightforward, because mass is one of the fundamental physical quantities. Then mass is measured in kilograms. And acceleration is determined here. Units of acceleration is ms minus 2. So units of force is kg ms minus 2. Units of force is kg ms minus 2. kg ms minus 2. Right? Okay, listen. But here there's another thing about this unit. There is something special about this unit. Look at here. Look at the board and listen. There is something special about this unit. That is in physics we have some units. Later on the units are given as, units are offered as, and honored to the founder, right? Honored units are there, the respectable units, which means now when listen, when scientists are doing researches and finding making findings on the things here in science, right? Now as an honor to that founding scientist, as a respect to that founding scientist, there are some units, they are labeled, they are offered as an honored unit, and usually the honored unit is considered as the SI unit, right? So one such example is this. Right? Now, the founder of the external balance force, however, is we call force. Founder of force and external balance force was Sir Isaac Newton, right? It was Sir Isaac Newton. So therefore, as an honor, as a respect, right? As a recognition for that founding scientist, this unit was honored as, this unit was labeled as newtons. So that is why we measure forces in newtons, and newtons has become the SI unit, standard unit. Newtons තමයි මෙයාගේ standard unit එක. එතකොට හැබැයි newtons කියන එක ඇතුලේ තියෙන්නේ මෙන්න මේක. What is inside newtons is this. This unit is offered as or denoted as newtons as an honor to that founding scientist, Sir Isaac Newton. Is it clear? So therefore, so likewise units are there, such units are there. Right? Such units are there. So in such cases, we call this as the derived unit. And we call the SI unit as the standard unit or the SI unit. Is that clear? Use a red pen. Use a red pen and put an asterisk mark here and write down below this. Put an asterisk mark here and write down, but SI unit of, write down, but SI unit of, force, is newtons. Newtons. But SI unit of force is newtons within brackets capital N. But SI unit of force is newtons. Right? So idea is this. Look at here. Idea is this, which means kg ms minus 2 equals newtons, which means this. This is the unit which is derived from our fundamental physical quantities, right? But as a respect to the founder, ultimately the unit is denoted as newtons, right? So in such cases, listen and look at the board. In such cases, this unit is called the SI unit. This is the SI unit, and this is called derived unit. This is called derived. See, this is called derived unit. Take this down and a square arrow highlight like this. And label SI unit and derived unit. Right? Label SI unit and derived unit. Right? So therefore, as the SI unit, we will refer only newtons for force. But if there's a requirement to expand newtons, to see what is inside newtons, we can expand newtons as kgm is minus 2 with the requirement, right? Otherwise, SI unit of force is newtons. SI unit of force is newtons. SI unit of force is newtons. So what's the meaning of SI? Standard International. SI means Standard International. SI. Standard International. Standard International. SI units are the standard that we follow for entire Earth. For entire Earth, that's the standard. That's why we call that is Standard International. They are not Sri Lankan units. They are not Asian units. They are not European units. They are Standard International units, SIs. Right? So wherever you are in the world, you write the force as newtons. Wherever you are in the world, you write velocity as ms minus 1. Wherever you are in the world, in which country you are, doesn't matter which language we speak, doesn't matter which culture we belong to, doesn't matter which country we are in, right? Always SI units are SI units. They are same throughout the world. Any other questions? Okay, so far now we have discussed 5 derived physical quantities. We have discussed 5 physical quantities, 5 derived physical quantities so far. Any questions up to here? Any questions? Quickly, you can ask. You can ask if there's anything. Any other questions? Or is it all clear up to here? No. All right. Clear. Right. Okay. Right. Right. Let's move on. Next one. Next one. Number 6. Number 6. Number 6. Linear momentum. Linear momentum. We denote it by P. And linear momentum is the product of mass into velocity. That is the product of mass m times velocity. Velocity v. So therefore, this is called P equals mv as an equation. P equals mv. Okay, try it. Try it. Linear momentum. Try it. Try it. And I highly encourage you to finalize and conclude your classes for all 3 subjects latest by the end of July. Now it's 22nd, 22nd of July today, and now you have 1 week more, right? Finalize your classes, conclude your classes latest by the end of this week. Then classes වලට පැන ඉන්න ආයි මේ time එක තියාගන්න එපා. That will be a waste, because everything in physics, especially in physics, are connected from beginning to the end. Right? Everything are connected. They have their internal links. Because if you miss the first day, you will break that link between the first day and the second day. If you miss the second day, you will break the link between the second day and the third day. Right? So likewise, everything is linked here. And all these units and lessons are put with a rational order. Right? Rational order එකකට තමයි මේ units එක දාලා තියෙන්නේ. ඒ order එක තමයි the way you learn. Now, the reason to have units and dimensions as the first unit under measurements is units and dimensions will be used throughout all 10 units. That's why. Logical load ekkada thamai meka dala thiyena. Therefore, don't miss any classes, and if you miss my class for any unavoidable reason, right, unavoidable reasonable reason, you can always request the recording from me, then I'll share the recording with you, and during the same week go through the recording and make your note and complete your note and come to the next class. Then you won't break that flow of the class, right? So always that flow has to be there, right? Yes. Units of P is units of M times units of V. Units of P will be units of mass is kilograms. Units of velocity is ms minus 1. So units of linear momentum is kg ms minus 1. Units of linear momentum is kg ms minus 1. Right. Clear now? Clear, right? 7. Let's move on. 7. Work. We do not work by W usually. Work. So no, before work, let's do pressure. Pressure. We denote pressure also by P, same P, right? And that is perpendicular force over area. Perpendicular force, not just a force, perpendicular force over area. Perpendicular force over area. Right? So as an equation, I can say pressure equals P equals F over A. Pressure equals F over A. Right? Yeah, I see some answers. Nm minus 2. Yes, good. All right. Others, any other different units you have? Anyone who has got different units other than Nm minus 2? Are there anyone? Are there anyone who has got a different unit other than Nm minus 2? Anyone who has got a different unit other than Nm minus 2? There can be students who might have got different units other than Nm minus 2. Anyone? No? All of you have got Nm minus 2? Yeah, kg m minus 2 s minus, sorry, kg m square s minus 2. You say kg m minus 2 s minus 2. Okay, another one says pascals. Another one says pascals. Okay, let's see. What's the reason to have different units like that? Right? See, now when it comes to units of pressure will be units of force into perpendicular force over units of area, no? Right? Now, always when we plug values, always when we plug values, we plug the SI values, standard international values. Standard international units. Always when we plug units, we have to plug the SI unit. SI unit. Look at here. So pressure is SI unit of force is newtons, and SI unit of area is we determined before m squared, right? So therefore, this is correct. Nm minus 2, this is correct. Nm minus 2, this is correct. This is correct. Correct. But we know if we need to expand newtons, we can expand newtons as well. If we need to expand newtons, we can expand newtons as well. Because we know that newtons is kgm is minus 2. That we know already. Newtons can be expanded as kgm is minus 2. So therefore, when we find out units here, now under unit 1, the whole purpose is you should be able to derive units and you should be able to deal with units, deal with fundamental units, derive units, and you have to know the SI units, right? So that's the purpose of this unit 1 and the unit section, right? So therefore, when you find units here onwards, listen, when you find units here onwards, if you see 1 or 2 or more than 2 derived units for a given physical quantity, find all derived units as well, right? ඔයාලා හිතනවා නම් මේකට තව units තියනවා කියලා, derived units derived units තව තියනවා නම් ඒ තියෙන ඔක්කොම ටික හොයන්න මෙතනින් එහාට, right? So if you can see that there are more derived units for the same physical quantity, right? Find them out all, right? Now I'm going to expand newtons in my second step. See, I know newtons can be expanded as, මම මෙතනම expand කරන්නම්. Newtons can be expanded as kg ms minus 2 times m minus 2. Simplify this. So from here kg m to the power 1 and m to the power minus 2, the result is m to the power minus 1 and s to the power minus 2. So this is another unit. Because we know newtons can be expanded using this. Newtons can be expanded, that we know. Newtons can be expanded. And listen, and if there are no more expandable units here, which means you have got all units, which means you have reached the first derived unit, right? Kg expand karanna bෑ because kg is one of the fundamental unit, and meters is one of the fundamental units, and seconds is also one of the fundamental units. They cannot be expanded. So therefore, which means this cannot be expanded further. Is it clear? What about you? Is it clear, students? Is it clear? Yes, ne? Okay. Now here also there is a very similar thing as we had in force, right? A similar thing as we had in force. So I saw in the chat box also there was someone who was mentioning about pascals, right? The reason to have pascals, the reason to have unit pascals for pressure is, now that is also an honored unit. Again, the pressure was found by the scientist called Pascal, right? Pressure, the researches and the findings about pressure was done by a scientist called Pascal. So as an honor to that scientist, the unit of pressure was ultimately or eventually denoted as pascals. So therefore, pascals is an honored unit and pascals is the SI unit of pressure. Pascals is the SI unit of pressure. Right? Okay. Write this down with a red pen. Put an asterisk mark. Put an asterisk mark with a red pen and write down. But SI unit of SI unit of pressure is 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 pascals. SI unit of pressure is pascals. Pascals is how it is written. Pascals. Capital P simple A. Capital P simple A. Yeah? Capital P simple A. Not simple P. Capital P simple A. Pascals. Pascals. Clear? So therefore, right, this is the idea. Pascals equals Nm minus 2 equals kg m minus 1 s minus 2. Now you have to know about these expansions because if you get to expand this, you should know. If you get to expand this, if you need to expand this in an instance, you should be able to expand it, right? So write this down like this and highlight it, right? You can square or highlight. You can square or highlight like this. And now in this case, it is like this. In this case, it is like this. Pascals is the SI. Pascals is the SI unit. SI. And both of them are derived units. Both of them are derived units. And for a given physical quantity, there can be any number of derived units. For a given physical quantity, there can be any number of derived units. Right? Now, as I told you, if there are more derived units for a physical quantity, now in coming up parts, the questions in the coming up equations, if you see there are more derived physical units, so you have to find them all. You can find them all one by one. Okay. Is it clear? Is it clear up to here? Okay. Right. Next one. Number 8. 8. 8. Work. W. You know this equation of work. You know this equation of work because this is in O levels as well. Work. Equation of work is what? Force into displacement. Force, capital F, times displacement. Displacement. S. Right. So therefore, equation of work is W equals Fs. Right. 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 Newton meters. I got one answer in the chat box. Newton meters. Now, if you have more, find them out all. Find them out all. If you have more. Yeah, I see some answers in chat box. Good, good. Keep going. Keep going. Okay, good. It's good to see. It's yeah, good to see that you are getting answers. Good, very good. Let's see. Units of work is units of force into units of displacement, right? Units of work. Units of force is newtons, right? Newtons. And displacement is meters. So we have 1 unit here, Newton meters. We have 1 unit here, Newton meters. One first unit, right? Now here also, if needed, you can label them. This is one of the units, and this is the second unit, and this is the first unit. And now we know, other than that, we can expand newtons. No? We can expand newtons. Newtons can be expanded as kg ms minus 2 times meters. Then from that, we can get kg m squared s minus 2. That is another unit. So that is unit 2. That is unit 2. Now, if you check that unit, you will see that it consists of kilograms. Kilograms is a fundamental unit. Meters is also a fundamental unit. And seconds is also a fundamental unit. So which means it cannot be expanded further. It cannot be expanded further. Is it clear? It cannot be expanded further. Right? So therefore, that's it for derived units. But this is also like pressure and force. As an unknown to the founder, there is an unknown unit for this. That is called joules. That is called joules. I know you, all of you have heard about joules when it comes to work and energy, right? So that standard unit is joules, right? There is none of them. That is joules. Therefore, both of them become what? Derived units. When they become derived units. And the SI is joules. Okay, first write up to here. Come up to here. Come up to here. And write down with a red pen with an asterisk mark. Put an asterisk mark with a red pen and write down. But SI unit of SI unit of SI unit of work SI unit of work is joules. Joules, capital J. Yeah, so I have written in the board if you don't know, right? But the SI unit of work is joules. Joules, right? So again, the idea is like this: joules equals Newton meters equals kg m squared s minus 2. Square or highlight this. Joules equals Nm equals Newton meters. This is called Newton meters. Nm equals kg m squared s minus 2. Highlight it. And now I hope this is clear. Joules is the SI. This is the SI unit. And both of them are derived units. Both of them are derived units. the reason to know about these derived units are, you will get expansions sometimes as questions. So where you need to expand and see what actually that unit is, right? So expand කරගන්න නම් මේ expansions ඔයා දැනගෙන ඉන්න ඕනේ. So expansion එක තමයි ඔයා expand කරගෙන එක types of questions එනවා, we'll see in the future. එහෙම තමයි මේක වෙන්න ඕනේ. Right? So by the end of this class, you will get to know all the theory parts about units. So simply, which means we are going to finish units today. We are going to finish units today itself. And next day, I'm going to start dimensions. Right? Next day, we will be starting dimensions. Right? Finished? Finished, right? Next one. Next one. Number 9. Number 9. Number 9. Kinetic energy. So you all know the equation, eh? You all know the equation. I'll also mention the equation. Kinetic energy. Kinetic energy. Usually we denote it by Ke. Half times mass m times velocity. You can't see the equation. Half times mass m times velocity v squared. Velocity squared. Right? Now, if I symbolize this, I can write this as Ke equals kinetic energy. No? Ke equals half mv squared. Right? Right? And once you get answers, put them to the chat box. If you are in the class from first day onwards, and if you do everything from the beginning with your fullest effort, A levels is not going to be that much difficult journey. But if you didn't work hard, and if you miss the things, A level is definitely going to be the most difficult journey you have in your lives. Think about what's happening with half. Think about what's happening with half. There's a small thing in there. You have a half there. Think about half. That will be very good if you get it before I explain. Yeah, again, I see some set of different answers in the chat. So my hint is think about half. And another one says what's no. Okay, answer this question. A small question. Listen all. Stop your work and listen. Stop your work and listen. Right. Half is a number. Right. That's clear for everyone. Half is a number. Right. And in maths we call these kind of numbers. We call these kind of numbers as coefficients. Right. That's a number. හරි maths වලදී coefficients කියලා අහලා ඇති same thing හරි coefficient එකක් කියලා කියනවා equation එකක number එකක් තියෙනවා something like this see y equals 3x right that is an equation so this is a number and in maths we call that the coefficient කියන වචනේ අහලා ඇති coefficient right so simply that is a number. My question is, listen, what is the unit of a number? My question is, what is the unit of a number? What is the unit of a number? What is the unit of a number? What do you think? What's your thought? What's the unit of a number? You know numbers 1, 2, 3, 4, 5, 6, likewise. Now we are counting numbers from the very childhood, from the very infant stage of us, right? What's the unit of numbers? Okay, look at here. If we think of numbers, listen, this is an important point, and I'm explaining this for the first time in this class. Right? When it comes to numbers, right? Numbers are just numbers without units, no? Because when I say 1, I don't say unit. 1, that's it. 1, 2, 3, 4, 5, 6. Just the number. So therefore, numbers don't have a unit. So therefore, numbers are unitless. Look at here. So one thing here is numbers are unitless. Don't write this. I'll give you the note. Just know that numbers are unitless. Numbers are unitless. Now I'm determining units of this, no? See? Then units of kinetic energies, units of half times, units of m times, units of v squared. Right? But I know numbers are unitless. If there is a physical quantity or a number or any other instance where there is not having units, that don't have units, right? Either you can ignore writing it, because the reason is if that particular physical quantity or if that particular number doesn't have a unit, which means there is no contribution from that number to the final unit, no. So therefore, one thing we can do is we can ignore writing it. Right? Unitless case, they are unitless. So either we can ignore writing them. Ignore writing them, or else we can consider them as one. Because it's not going to harm the equation. 1 into anything is the same thing, no? 1 times x is x, 1 times y is y. So therefore, the next option is both are fine. You can get used to anything you prefer, and you better know both. Either you can write it as, consider it as 1, or considering it as 1. Either ignore or consider as 1. Ignore or consider as 1. Okay, look at here. This one now. This one. So we can ignore this. Right? Or number එක කෙලින්ම ignore කරන්න. එහෙම නැත්නම් 1 කියලා ලියා ගන්න. Right? Numbers are unitless. So therefore, this is 1 and mass is measured in kilograms, and V is measured in, that's velocity, no? ms minus 1, and it's square. Like this. Simplify this. We will get kg m squared s minus 2. Right? So that is not going to be half kg m squared s minus 2, or that is not kg m squared s minus 2 over 2. No. Units කියන එක divide වෙන්නේ නැහැ. What is meant by centimeters over 2? No meaning. Right? No meaning for that. Centimeters over 2, no meaning. Right? So therefore, since the number doesn't contribute for unit, we can ignore writing it, or either write it as 1. Unit එකට contribute කරන්න මෙයා විතරයි. mv squared. Since number is unitless, the final unit of kinetic energy is determined by the unit of mv squared. Numbers are unitless. So now you know one instance where they don't have units. That is numbers. Numbers don't have units. Okay. Tell me whether it's clear. And in the chat box, I saw most of you were considering half and simplifying half with the unit. No, that's not the thing. Unitless. So no contribution for unit. Okay, now tell me whether it's clear. Is it all clear? Okay, clear. All right. So first take this down, then I'll give you the note. Take this down. So unit of kinetic energy is kg m squared s minus 2. Now you can compare it with this. See, kg m squared s minus 2. Right? Which means that is same as joules. So therefore, SI unit of energy is also going to be joules. So after this point, keep in mind that SI unit of work and energy are same as joules. SI unit of work and energy. Work and any form of energy, any type of energy, not just uh, not just kinetic energy. There are different types of energies, no? Like kinetic energies, potential energies, heat energies, sound energies. Different types are there. Any form of energy is measured in joules, only in joules. All right. Then write this down below. Therefore, kg m square h minus 2 equals joules. Okay, take this down. Take this down. Right? Okay, again, with a red pen, mention this, put an asterisk mark and mention this in red. Mention this in red. Therefore, 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 SI unit of, therefore, SI unit of, therefore, SI unit of, therefore, SI unit of any form of energy, any form of energy, any form of energy SI unit of any form of energy, SI unit of any form of energy and work is joules, is joules, is joules. Right? So මෙතනින් පස්සේ හොඳට මතක තියාගන්න SI unit of SI unit of energy and work are same as joules. That's same as joules. Right? Next point, keep using the red pen. Next point, keep using the red pen. Next point, numbers are unitless. 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 Next point. Next point. Unitless parts of an equation. Unitless parts of an equation. Unitless parts of an equation can either be ignored. Can either be ignored. Can either be ignored. Can either be ignored or written as one. Or written as one. Can either be ignored or written as one. Can either be ignored or written as one, as they don't have a contribution, as they don't have a contribution, as they don't have a contribution on units, as they don't have a contribution on units. Okay. Take this down again and highlight or square this. This one, nah? This one. Take this down again and highlight or square this. Take it down again. Right? Next one. Next one. What's the number? 10. 10. Gravitational potential energy. Gravitational potential energy. We denote it by PE. Potential energy. We denote it by PE. And that is mass times mass, simple M, times gravitational acceleration. Gravitational acceleration. Simple G times, I'll be erasing this. Times vertical height. Vertical height, simple H. So therefore, as an equation, this can be written as PE equals mgh. Okay, right. P equals mgh. Right. Right. Yeah, now I can see some correct answers in the chat box. Yeah, good. Good, good. Good. Yeah, you can put your answers to chat. So this is also a form of energy, no? Right? Gravitational potential energy. So with the previous one also I told you that any energy is measured in joules, no? So therefore, this will also have the same units of joules. This will also have the same units of joules. This will also have the same unit of joules because this is also an energy. Right? That is also an energy, right? Good. So units of P equals units of mass, units of G into units of H. Right? PE equal units of mass, kilograms. Units of G. G is gravitational acceleration. Listen, G is gravitational acceleration. Gravitational acceleration is also an acceleration. No? Gravitational acceleration is also an acceleration. Right? So that is what it matters. Whether it's an acceleration or velocity or force or pressure, that is what matters. No? Gravitational acceleration is also an acceleration. So we know units of acceleration from the previous one. That is ms minus 2 times vertical height. Vertical height is a length. Vertical height is a length. Length is measured in meters. Length is measured in meters. So P equals kg. Simplify this. Kg m times m is m squared s minus 2. Kg m squared s minus 2. So we know that is again joules. That is again joules. Right? So again you can mention that kg m squared s minus 2 equals joules. That is joules again. That is joules again. Yes, joules. Right? Okay. Finished? Okay. Mention this again with a red pen. Mention this again with a red pen with an asterisk mark. Mention this again with a red pen. Both energy and work. Both energy and work. Both energy and work. Both energy and work. Both energy and work is measured in joules. Is measured in joules. Both energy and work is measured in joules. Right? Okay. Next one. 11. 11. Next one. Write down 11. Power. Power. That is also capital P. Power is, so you know the equation. Power is, there are two equations, energy over time. Right? E over T. Or it is also called work over time because work and energy are same, no? That's why. Work over time or energy over time, both are correct. Both are correct. Right. Both are correct. Right. Right. Energy over time or work over time, both are correct since work and energy are same. Work and energy are same. Okay. Right. And I want you to find all possible derived units. I want you to find all possible derived units. I need all possible units, all possible derived units. kg m squared s minus 3 j s minus 1. Good, keep going. J s minus 1 kg m squared s minus 2 volts. Okay. And make sure you have got all the units. Make sure you have obtained, you have found all possible units. Yeah, I'm looking at your chat box. Yes. Yeah, it's happy to see that you are getting answers, you are engaging. Yeah, good. Very good. Okay, how many units altogether? How many units altogether? In most of the answers, I have seen 2, 3 units. Anyone who has got more than 3 units? The maximum number of units I have seen in the answers so far is 3. Anyone who has got more than 3 units? 3. Anyone who has got more than 3 units? Is there anyone who has got more than 3 units? No? No? If you have got more than 3 units, just tell me. Right? So is that 3 maximum for all of you? Anyone who has got more than 3 units? Okay, let's see. Let's see. Look at here. Look at here. So the equation is, look at here, equation is power equals energy over time. No? Power equals energy over time. Then units of power is units of energy over units of time. Right? I'll start substitution from joules because energy is as the SI unit, energy is fundamentally measured in joules. So power equals energy is measured in joules. Joules over time is measured in seconds. So from here I got one equation, one unit as Js minus 1. This is 1. Js minus 1. You can check your answers, right? You all can check your answers. Js minus 1. And then for joules, I know another expansion as Newton meters. No, so I'm going to go with that. Because I know joules can be expanded as Newton meters. We proved it before under work, right? So therefore, see power, and now I'm going to expand this joules as Newton meters, right? No problem, no? Newton meters over seconds. So it gives us Nm s minus 1. Nm s minus 1. That is my second unit. Nm s minus 1, second unit. And now I see newtons here. I can see newtons here. And I know newtons are further expandable. Right? Newtons are further expandable. Now I'm going to address newtons. Next one. I'll be writing the rest here. Power equals. Now it was Nm always no, right? Nm always no. So if I expand newtons, see this force, the previous one was, let me expand it here. It was Nm s minus 1. Now, if I expand newtons further, I can expand newtons as kg ms minus 2 times this is ms minus 1, right? So power equals, simplify this, kg, m times m is m squared, s minus 2 times s minus 1 is s minus 3, s minus 3, s minus 3. This is another unit, that is unit 3, right? That is unit 3. And in the answers I saw in the chat box, most of you were missing this. Right? Most of you are missing this. If you are finding all possible units, then this is also possible unit. All possible units, no? This is also possible unit. But when it comes to power also, listen, when it comes to power also, this is also having an honored unit that is called watts. So with watts, altogether we have 4 units for power. SI unit will be watts. SI unit is watts. Okay, first come up to here, right? Come up to here if you haven't get this, if you haven't got these units. First come up to here quickly. Come up to here quickly. Finished? Okay, here mention this with a red pen with an asterisk mark. Put an asterisk mark and write down in red. But SI unit of, write down in red. But SI unit of, but SI unit of SI unit of power is, SI unit of power is watts, like this, WA-T-S, and symbol is capital W. But SI unit of power is watts. 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 Right? Okay, now you can collect everything together here, which means, see, watts equals what? Js minus 1 equals Nms minus 1 equals kg m squared s minus 3. So highlight all or square them all. And in this case, you know, this is the SI unit. What is the SI unit? All 3 of them are derived units. All 3 of them are derived units. Okay, finished? Finished? And any questions up to here? Any questions up to here? Quickly. Any questions up to here? Any questions up to here? Or is it all clear up to this point? Now we have derived how many? 11. We have derived 11 derived physical quantities by far. We have derived 11 derived physical quantities by far. Any questions? Okay, good. Okay, right. All right. All right. Now let's see a small exercise. Right? Let's see a small exercise. Now after this, the derivation part, derivation of the physical quantities that you need to know under unit 1 is finished. Right? Now let's see an example question exercise. Huh? Okay, we'll erase this. Okay, take this down as a question. This is an exercise. Take this down as a question. Write down. Write down. Write down the question. Write down the question. Find all possible. Find all possible. This is a question. Question. Write down all possible. Write down all possible. So what did I say? Write down or find. Find kill the find all possible units. Find all possible units for the ratio energy per unit volume. For the ratio energy per unit volume. For the ratio energy per unit volume. Energy per unit volume. Energy per unit volume. Okay. Look at here. Look at the board. So first thing is now when this is given in words, now I'm going to convert this to an equation or a ratio. Then we can clearly see this note. Otherwise, we can't deal with words when we are doing something mathematical, right? We are doing something mathematical. We are going to simplify, and we are going to do some sort of a simplification and get a derived unit. So therefore, we have to write this as either as what? Either as a ratio or an equation, right? So you have to have this basic idea. Look at here. See, if you don't know, you can take this down as a note. Look at here. Let's say I have x over y. Let's say I have x over y. X over y. This is called x per unit y. This is called x per unit y. This is called x per unit y. Or this is also called ratio between. This is also called ratio between x and y. Ratio. This is also called ratio between x and y, right? So both of them are correct. So if you don't know this, first you have to know this, right? Because when it comes to questions, sometimes you will be given as a ratio, sometimes you will be given it as in words, right? Sometimes as an equation, right? So whatever it is, you have to know this. You have to know this, right? So take this down as a note. If you don't know before the question, take it down as a note. X over y is read as x per unit y. x per unit y. Always denominator term is considered as a unit term. Now, one example is, see, let's see an example here, a very popular example. Rho equals MOV, no? Rho means density. Density equals MOV, no? Let me write in words first. This is an example. Huh? Density equals mass over volume. Right? Density equals mass over volume. We denote density by rho. This is a Greek symbol. Rho, Greek symbol. M and volume V. So therefore, this is written as rho equals MOV. Rho equals MOV. Right? Now, denominator term is always considered as a unit term. So therefore, this is defined as mass per unit volume. This is defined as this. Mass per unit volume. Mass per unit volume. So this is the idea. This is defined as mass per unit volume. Right? Take it down. Sir, density is not there. Density is not. You're asking for the units? You're asking for the units? Yeah, if needed, we can find out. Since density is a very common one, I didn't take it to the list that we derived units of. Otherwise, if you need density, now first write this down. This is something additional for what I have written here. If you need to find out units here, that is also possible if needed. Density, units of density equals units of mass over units of volume. Units of mass is kilograms, units of volume is m cube. So that is kg m minus 3. Units of density is kg m minus 3. If anyone needs, you can take this down. Right? So that is how the units will be. Kg m minus 3. Kg m minus 3. Salman, you asked about the units, right? Yes. Okay. Good. Okay. Finished? Finished. Now, with this understanding, first convert this given question to a ratio. First convert this given question to the ratio. First convert this given question to the ratio with that understanding. Convert this to ratio. Energy by unit volume, no? See? Then energy by unit volume should be written as energy over volume. Energy over volume. Energy over volume. So that is energy is E, no? And volume is V. Right? Okay. Now, this is the ratio. This is the ratio you have. Energy over volume. Right. Now, I need you to listen. I need you to find out all possible units for energy per unit volume. Start. How many? Yeah, someone has sent 3 units. Yes, good. But check again, there are more units. I need all possible units. Right? Try to find all possible units. Try to find all possible units of energy per unit volume. Yeah, very good. Now, one has sent 3. Another one has sent 3 units. And I say there are more than 3 units. There are more than 3 units. Check again. Now, the answers you have sent are already correct. Right? What I'm saying is there will be more units. Okay, right? I'll give you like 3 minutes. I'll give you 3 minutes. Right? And meanwhile, if you got any questions, anything to clarify from my side, you can put them to the chat box, right? You can put them to the chat if there's anything. How many minutes? All right. I'll start in another minute. Yeah, I can see you have got 3 units. Most of you have got 3 units. But look carefully, watch carefully, and look carefully. There are more than 3 units. There are more than 3 units. Check it carefully. Watch it carefully. Okay, let's see. Let's see. Energy by unit volume, right? So I can start with, look at here. I can start with energy is measured in joules, no? Joules. Or volume is cubic meters. So I can start with this. Jm minus 3. This is my unit 1. Jm minus 3, that is my unit 1. Right? And now I'm going to expand joules. Second step, I'm going to expand joules as Newton meters. Newton meters over m cube. Simplify this. That will be nm minus 2. This is my unit 2. This is my unit 2. Right? Then we know we can expand newtons as I'll do it here, kg ms minus 2 times meters here over cubic meters, right? Now from that we will get, simplify this, kg m minus 1 kg m minus 1 s minus 2, that is my unit 3. Kg m minus 1 s minus 2, that is my unit 3, right? And I saw most of you have got these 3 units, right? Yes. Yeah. Most of you have got these 3 units. And there is another unit. That is you should see this from here. The easiest point to see, that is here. Nm minus 2. That's a kind of a popular unit. Nm minus 2. Nm minus 2 is a unit of what? Tell me. Nm minus 2 is a unit of, now from our non-physical quantities, tell me, Nm minus 2 is a unit of what? Tell me, from our non-physical quantities. from physical quantities. What's the physical quantity? What's the physical quantity relevant to Nm minus 2? That's physical quantity is pressure. Physical quantity is pressure. Physical quantity is pressure. So therefore, from here we can identify that this as a pressure. This is a pressure. So therefore, Pascals is also a possible unit, right? So from here we can see this is a pressure. That is a pressure. So therefore, Pascals is also a possible unit. That is unit 4. Pascals. So altogether we have 4 units. Altogether 4 units for this. So which means this ratio represents, energy per unit volume represents a pressure. Energy per unit volume represents a pressure, right? So by checking units, we can identify such things as well. Energy per unit volume, that's not a popular ratio. That is an unknown ratio. That ratio represents a non-physical quantity, that is pressure. Okay, complete it, take it down, complete it. Finish. Okay, mention this below with a red pen. Mention this below with a red pen. Put an asterisk mark and mention. Put an asterisk mark and mention this below with a red pen. Therefore, energy per unit volume. Therefore, energy per unit volume represents. Therefore, energy per unit volume. Therefore, energy per unit volume represents. Therefore, energy per unit volume represents pressure. Therefore, energy per unit volume represents pressure. Energy per unit volume represents pressure. Okay. All right. Tell me, any questions up to here? Up to this point? Any questions up to this point? Or is it all clear? Any questions up to this point? Clear. Good. Clear. Okay, good. Right. As the next heading, write down prefixes. Next heading, prefixes. Next heading, prefixes, like this. Prefixes. Right. Okay, prefixes means something like this. Listen. Prefixes means something like this. Now, when we deal with units, if we are dealing with two small numbers or two large numbers, to easily write it without numericals, right, we use prefixes, right? And always the prefix is defined with respect to the base unit. Prefix is defined with respect to the base unit, something like this. Look at here. Now, once I explain this, you will understand this better. Look at here. Now, let's say this is the base unit. And prefix is with the deviation from the base unit, right? And for the positive 10 to the powers we have, there is a pattern here. So keep that pattern in mind, right? So it goes as this. Kilo, mega, giga, tera, right? And this is simple K, capital M, capital G, capital T. And their value varies like this. Kilo means 10 to the power 3, mega 10 to the power 6, giga 10 to the power 9, tera 10 to the power 12. 10 to the power 12. Right? And for negative values also, it's same. It's like milli, micro, nano, pico. Milli, micro, nano, pico. Right? Milli, simple m. Micro, mu, this is symbol. Nano, simple n. Pico, simple p. Right? Milli means 10 to the power minus 3. Micro, 10 to the power minus 6. Nano, 10 to the power minus 9. Pico, 10 to the power minus 12. So this is a standard series of prefixes. And this is the pattern. This is the pattern. Right? 3, 6, 9, 12. This is minus 3, minus 6, minus 9, minus 12. Right? Okay. First take this down. Then I'll explain you the use of this. Right? I'll explain you the use of this. Take it down. Take it down. Take it down. Right. Okay, finished? Finished? Okay. See, the use of this is like this. See, this is an example. This is an example. Look at here. Say, I have, if I need to convert this to meters, right? If I need to convert this to meters, we know kilo means 10 to the power 3, no? So it is like 100 times kilo means 10 to the power 3 meters. Because kilo is the prefix. Kilo is the prefix. So which means it gives this altogether 10 to the power 5 meters. 10 to the power 5 meters. Right? So either way, we can convert it back and forth. Let's say I need to write this value in megameters. I need to write this value in megameters. I know mega is 10 to the power 6. Mega is 10 to the power 6. Then to apply mega, to write mega, I have to have a 10 to the power 6 in my number. So I'm going to create one. See, this is also possible. This is example 1. Now here 100 kilometers can be written as, see, now let's start from here. Now 100 kilometers is written as 1 times 10 to the power 5 meters, no? To include a 10 to the power 6 without harming the number, I can write this as, to include 10 to the power 6, no? We can write this as 0.1 times 10 to the power 6, no? That's still the same. That is still the same. Same number comes. 0.1 times 10 to the power 6. Right? Meters. Meters. But we know 10 to the power 6 is mega, no? If I need to include this, that is mega. That is mega. So therefore, I can write this as 0.1 megameters. 0.1 megameters. Right? So either way we can, either direction we can convert it back and forth. And the third one, let's say, now this is 1 times 10 to the power 5 meters. And I need to convert this to, let's say, millimeters. I need to convert this to millimeters. Milli is 10 to the power minus 3. Then we can rearrange this using a 10 to the power minus 3. So what we can do is, if I write this as 1 times 10 to the power 8 times 10 to the power minus 3 meters, no change for the value. No change for the value of the number. 10 to the power 8 times 10 to the power minus 3 again gives us 10 to the power 5. Right? But my intention is to include 10 to the power minus 3 because that is milli. Now this can be written as milli. This can be written as milli. This can be written as milli. So therefore, this value is 1 times 10 to the power 8 millimeters. 1 times 10 to the power 8 millimeters. So likewise, we can convert those numbers, values back and forth using prefixes. එතකොට prefix එක තියෙනවා නම් ඒක base unit එකට convert කරගන්න පුළුවන් වෙන්න ඕනේ. Base unit එකෙන් ඕනේ prefix එකට convert කරගන්න පුළුවන් වෙනත් ඕනේ. That's the purpose of this. Right? And always these are the deviation from base units, which means kilo is 10 to the power 3 times base unit. Mega is 10 to the power 6 times base unit. Right? This is valid for any unit term, a standard series. If there is grams, let's say, then kilograms, megagrams, likewise it goes. Milligrams, micrograms, it goes. And if there is, let's say, you are taking newtons. Newtons is the base unit. Kilonewtons, meganewtons, giganewtons, teranewtons. And here millinewtons, micronewtons, nanonewtons, piconewtons, likewise, so on and so forth. So likewise, for any base unit, this is the prefix. Prefix means, pre means front, no? So that is the value that comes front, at the front, like this. So take this down, this example. Take this down, this example. Take down the example. Take down the example. And you can raise if you have any questions, anything to clarify. If there's anything, you can raise now. Okay, finish. Finish there. Okay. Okay, listen. 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 Right, finish now? Okay. Yes. Okay. All right, listen. Now, from here, I mean, at this point, we have finished all the things that you need to discuss in units. So, which means simply we have finished units now. Right? Finished units. And next day plan is, listen, next day plan is, first we will discuss few questions from units. Past paper questions. Next day we will discuss few past paper questions from units. Then you can see how the questions have come from past papers from these areas, right? So today we start from stretch, and we have come to the end of units now, right? Next day, I'll be starting the class with a discussion of few past paper questions, right? And the main plan for next day is we are starting dimensions, and that is the next most critical part here in measurements, right? Here in measurements, because measurements consist of units and dimensions and measuring instruments. Under units and dimensions, we have two parts as units and dimensions. So today we finished units, and next day we are moving on to dimensions, right? And that is the next milestone part and the most critical part in the first part of measurements, right? All right. So next day, for the discussion of questions, I will discuss around 5-6 questions. For that, it will take like first 30 minutes of the class, and then we are starting dimensions. And that will be the most important, significant part. We are starting next day, right? And before next day, I'll be sending you the registration links. And if you are continuing the class, you can register using that link. And keep in mind that now for this month, since we are starting today, 22nd, for this month only a half month fee will be charged. I mean, only a half month fee will be applicable. Only a half month fee is applicable, which means you know, my regular class fee is 3,600. Regular class fees 3,600. For July, it will be a half month fee, that is 1,800 only. For July, 1,800 only. Now with the registration links, I will mention these details as well. So when you transfer that amount, make sure that you are transferring this, not the full month fee. For this month, only 1,800 will be charged, because for July we have only 2 days remaining, right? Today and another day, 2 days, only 2 days of the class, right? Keep that in mind. I'll give you all the updates on that WhatsApp group, and through the common updates through the Telegram channel, and all the updates regarding this batch, new batch 2027, will be through that WhatsApp group only, right? So therefore, make sure that you are in that group, and once I drop a message, you can check it out. But I have put, like, I'll be giving you updates only, right? I'll be giving you updates, all the updates through that group, right? So next day, as I told, we'll be starting dimensions. So don't miss the class if you are continuing the class, because that will be the next most important part here in units and dimensions, right? And in dimensions, we are going to more advanced questions, more depth compared to units, right? Compared to units, we'll have more depth in terms of everything, like calculations, thinking parts, simplifications, everything. We are going to more depth, right? And the area and the scope of dimensions is a little bit higher than what we have done here in units, right? And before the next class, please go through everything we have done today, we have discussed today, because as I told you, all the things here in physics will be interconnected, right? So first day learnings will be connected with second day, and first day and second day will be connected with third day. So likewise, it goes as a chain, it goes as a flow, therefore, in a weekly basis, always you have to go through these things before you are coming to the class, right? So if you work hard, and if you work according to the way that I'm asking you to do, going through A levels and going through the exam with a good rank, with a good result, is not going to be a magic. It's not going to be a miracle, right? As long as you work according to the work plan, right? Otherwise, if you didn't work, you won't get the expected result. That is how it is, because your effort will be always, effort reflects your result. Effort reflects your final result, right? So therefore, if you can work according to the plan that I'm giving, right? So today I didn't give any plan in regard to that, but later on I'll be giving you work plans according to the stage that you are in. So if you work onto that work plan that I'm asking you to do from today onwards to the last day, definitely you will go through without any hassle. Any other questions? Any other questions? Anything to clarify before winding up the class? Anything, students? Or is it all clear? Anything to clarify? Any other questions? Anything to know about the class? Any other details that you need to know about the class? Is there anything that I didn't mention? Is there anything that I didn't mention that you need to know? No, right? No? Yes, all clear. All clear. Right. All right then. Then yes, I'll finish the class here. I'll wind up the session here. So study hard today onwards. Work hard, study hard. Then going through A levels is not going to be a miracle, right? All right then. We'll finish the session here. So it's done for today, and you are leaving the class with the all knowledge gained regarding units. Now you know about units. Now you know everything, actually, all the things about units, and next day we will start dimensions, right? All right then. Then see you all in the next class, right? See you all in the next class. Good night and goodbye.
Thank you, sir. Good night, sir.
You are welcome.